drunk. Poor little dude. So, first question I have for you guys. Everybody's managed to access the textbook. Is this true? I heard a
I think so.
You think so? Okay, that's neat. You access something, and it might be the textbook.
Yeah.
Interesting. Okay. So,
Access and downloaded something. It said textbook on it.
dude, very interesting. What class you taking? Textbook. So please, dear God, if you have any trouble finding the homework, don't wait till week 5 or something. And I say that because it's happened.
Like, yeah, I didn't tell you homework because I wasn't able to find it.
Week 5. I'm like, what the hell? So as you guys do homework, you can bring questions. Yesterday we went on the field trip, and I showed you the Sissel and that sign. You're surrounded by people that want to help you. It's insane. Okay. Hey. So let's finish this up. I think last time we did the first 3 on this. How'd the part D go? Does anyone just straight up dislike any problems with fractions in them, period? Yes? Okay. But this problem specifically, I helped one group, if I remember correctly, out with this. And when you're, all right, 2 levels of this. When you're multiplying fractions, how do you multiply fractions? Straight across. Don't do that here, dear God. You're gonna make these big freaking numbers, because what do you want to also do with fractions very often at the end? See if they simplify. So I'd rather simplify first, make my number smaller first, before I make these big freaking numbers, yes? So here's the idea. Any factor on the top that is also on the bottom has to cancel. Because the numbers on the top want to multiply each other, the numbers on the bottom want to divide into those, yes? Since those are opposite operations, they will cancel. So if I look straight up and down, nothing factors here, nothing cancels, and nothing cancels here. But if I look this way, does anything factor and cancel here? Yeah. So what cancels there? And just to really do more work than you have to, I'm gonna make 15 5 times 3, and I'm gonna make 25 times 4. So then I can see the 5s die, yes? And the normal way you do this is you cross through this and you put a little 3, and you cross this, put a little 4. I'm just being overly pedantic with my work. Okay. What about 21 and 28? Here's something really cool. Let me see if you guys are cool with this. Do you guys see real quick 28 minus 21 is 7? If 7 goes into 2 numbers, those 2 numbers have to be multiples of 7. Ooh. Which means the distance between those 2 numbers has to be a multiple of 7. So if I subtract 2 numbers and they're 14 apart, what could go into both? 14 or 7 or 2? Or nothing. Yes. So it's kind of cool that if I look at the difference, it gives me an idea of what might go in. Shake ass. Maybe? Maybe. Okay. Bless you. So if I break those up in terms of 7, I get 7 times 4 and 7 times 3. And of course those 7s die. Now I can do what some of you guys told me to do. Just multiply across. What's the one time in the universe that you cross multiply? The one time in the universe that you cross multiply. Does anyone know? You all know cross multiplication, yes? You know what I mean when I say it?
When it's fully simplified? Or...
The only time you cross multiply directly is when you have fraction equals fraction. When I have an equation, one fraction equals another fraction. You guys with me? Because I get the biggest mistake I see on fraction problems is everybody's just cross multiplying everywhere. This would really suck, because then you're doing the exact opposite of what that's asking for if you cross multiply. Let me stop for a minute. You guys with me? I understand fractions are sort of universally aided, poor little dudes. They didn't ask to exist. We made them out of nothing, and they were like, why do I exist? So now that it exists, we gotta do stuff with it. So what's the answer gonna be? Say again? 9 over 16. Yes, multiply straight across. And now, since I made my numbers small to begin with, that was easier. Plus, I know the answer can't be reduced because I already reduced everything as much as possible. Now, I know real quick, I know some of you guys, you're cool with fractions, you're sitting there like, good lord, dude. And then some of you guys are like, holy shit, tell me more. I have students in my Calc 2 class that aren't good with fractions, so there's not a damn thing about what level you're at or whatever. Everybody has blind spots, and fractions seem to be a universal hated thing. Okay. Did that go okay? Does that make sense? I think I have E circled because I was asking people what the hardest problems were. And that one was hard for somebody because they forgot what the hell all that crap meant. Yes? Does anyone remember what a zero power does? Interesting. Okay, so let's take a look. Let's investigate. By the way, most classes are going to start with me talking a lot. You're going to make shut up. And I'll shut up and let you guys do some group stuff. Yes, group work. Some classes when I start, first thing we'll do is group stuff. We'll see. Okay. Today we got to finish this crazy thing up. Help me out. Remind me, guys. Can everybody remind me what would I do in this situation? Yes, right? Is that cool? Because how many x's up top? And what are they doing to each other? What are the 5 x's doing to each other? Multiply. That's why it's an x1, because x1 is a multiplication. How many x's on the bottom? 3. And I'm dividing this, right? So how many x's will survive? 2. I can just subtract then. It's a shortcut. 3 x's would cancel. I'd be left with 2. 5 minus 3. Let me freak you guys out real quick. In this, there is no 5. There is no spoon. There is no 5 in here anywhere. That means there are 5 x's. There is no 5. Are you guys with me? Because sometimes I'll put a 6 here and a 3 there, and somebody tells me the answer is x squared. They did 6 divided by 3. But I say, there is no 6. There is no 3. There's 6 x's, 3 x's. How many survive? Right? So the shortcut is 5 minus 3 is 2. And you guys are like, great, Jeff. Now tell me what the shit 0 means. Okay. How would I get this to be an answer? If I have x cubed on the bottom, what would have to be on the top so that I get x to the 0 answer? Because what do I do with these again? Subtract. So if there's 3 x's on the bottom, how many on the top to have the answer be x to the 0? 3, because 3 minus 3 is, holy shit. What is something divided by itself?
1.
So anything to the 0 power is 1, except 0. Anything to the 0 power is 1, except 0 to the 0, and that's, you'll talk about that in calculus. 0 to the 0 is truly freaky. What is 0 to any power? 0 raised squared, cubed. What's 0 to the 5th power? Freaking 0. What's anything to the 0 power? So what is 0 to the 0? It is somehow 0 and 1 at the same time. So we're going to leave that for calculus. Is that okay? You can see me in my office if you want more information. But for right now, we're going to let that be. Another reason why x to the 0 is 1. Let me ask you a silly question. How many x's are in that? 2. What's in front of the x? What's understood to be here?
1.
All right, is everybody cool with that? In front of every damn thing in the universe is an understood 1. What if I lost an x? How many x's do I have now? 1. What if I lost another x? How many x's do I have now? And what's the only thing left if I lose an x? 1. So x to the 0 literally means no x's. Therefore, you're only left with the 1 that's always there. That's another reason why x to the 0 is 1. I love you guys so much. You guys already doing okay? Okay. Do you want one more reason why x to the 0 is 1? Or you guys? You were thinking me like, good lord, no. Just stop. Okay. No, I'm gonna give it to you. What's the only number you multiply by and the answer is the same? Like, what do you multiply 5 by so the answer is 5?
1.
1. You with me? Does any other number act that way? If I multiply 5 by anything other than 1, it's going to be different, yes? What do you get when you multiply x squared times x to the 0? What do you do with the powers?
0, 0.
What do you do with the powers? Add them, yes? So what's 2 plus 0? Did it stay the same? So what must this be?
1.
1! It must be 1 because it's the only number I multiply by and something stays the same. Okay. So we're not going to forget that. Anything to the 0 power is 1. Okay. Good guess. Okay. Now I'm trying to remember why I went in the hole. Oh yeah, here. That's why. So what is 5 to the 0 power?
1.
Holy shit! Okay, thank God. If you guys wouldn't have said that, I would have cried. Now, a really good question is, that's great, Jeff. What the shit is a 1/3 power? Yes? So let's take a step back. Go with me for a second. What does the square root do to something? Like if I ask you, what's the square root of 25? What did you do to 25? Didn't you cut it in? No. You cut it in half multiplicatively, yes? Now listen, I want you guys with me. Half of 25 is 12 and a half, correct? Because when I say half of, it's implied additively. Well, if I say what's half of 25 multiplicatively, freaking 5, yes? You guys with me? Powers deal with multiplication, yes? So if I want to cut something in half multiplicatively, I can make that a 1/2 power. So if I have the square root of x, another way to write that, oh, here we go. Another way to write the square root of x is x to the 1/2 power. Because it cuts things in half. Now, really quick little mini rant. I wish we had never invented radical notation. The root is dumb. I wish we had never made it. Fractional powers are better. The only reason you guys like roots is because that's what you've been shown. Same reason you don't like metric system, probably. I don't want to make any assumptions, but does anyone here, can you all show me how long this decimeter is? Can you show me roughly how long a foot is? Can you, in the air, do it for me. How long is a foot? You guys are like, I don't want to do it. How long is a foot? Roughly this long, yes? I'm not going to come measure, you're fine. Can anyone show me how long a decimeter is? Of course we can't. Oh, I don't know. Did anybody grow up somewhere that used metric?
The tenth of the meter.
No. Huh?
Is decimeter 10?
Decimeter is 10 centimeters.
Oh, 10
So a foot is about 30, so 1/3 of a foot is about a decimeter. But is that like an automatic thing we know? Of course not, because we didn't grow up with that shit. Yes? Same thing here. Fractional powers are better. You might disagree with me just because you weren't brought up in it. Yes? Okay. So what do you think a 1/3 power means? Because that's the problem we have. If a 1/2 power means a square root, 1/3 power means a cube root. Which you could also think of as cut this number up into thirds multiplicatively. What number do I multiply by itself 3 times to get 8? 2. So 8 to the 1/3 power is 2. Because 1/3 of 8 multiplicatively is 2. What's 1/3 of 6? Additively. What's 1/3 of 6? You get 2. Why? Why? Because if I add 2 3 times, I get 6. So what's 1/3 of 8 multiplicatively? 2. Because when I multiply 2 3 times, I get frickin' 8. Get 8. So all fractional powers are variations of how to look at a root. Okay. And it makes more sense, to be honest. And you're all like, I don't know, Jeff, but maybe. So like we said, 8 to the 1/3 power is 2. 5 to the 0 power is 1. 2 minus 1? What? Okay. Sorry, I'll calm down. Did you guys do part F? Does somebody, if you didn't do it, are you able to do this kind of problem? Do you guys remember how to do this? what is it called? Yeah. Oh my God, little tears. A lot of times people say foiling. Do you guys know foiling?
Yeah.
The people that are shaking their head no, there's hope for the future. No, if you learn foiling, there's nothing wrong against you. It was your teacher that sucks. Foiling means first, outer, inner, last, which is bullshit. How many things are in front of x plus 4? The x and the 3, right? They each just get a term. It's just repeated distribution. That's all it is. There's no FOIL. That's bullshit. So the x gets a term. And then the negative 3 gets a term. Is that cool? And then you just put together like terms. Jeff, you could do it. Okay. Is that all right? And of course, factoring is what we're going to get into later, and that's doing all this backwards. Yay. Okay. So, if I look back at this, now FOIL sucks. First, outer, inner, last, because that only works if I have 2 and 2. The problem I gave you, you would have to have F, O, M, because you have a first and outer and a middle and a last, and oh my God, be that's bullshit. Much better to just go 2x gets a term, 3 gets a term. So go ahead, try it out. If you didn't try it out, just distribute the 2x, bam, bam, bam. Distribute the 3, bam, bam, bam. Get your like terms together. If you did it already, just sit there and stare in your favorite direction. 2, 4, 6. Okay, missing 5 people. 15. Let's see. Yeah, okay, we'll see. So you got 2x times 4x squared is 8x cubed, and then 2x times 6x negative x squared, 11, because we're accumulating x's, right? And then we get 2x times 9, 18x. And then what I normally do when I move to this other dude, 3 times 4x squared is, I just kind of line up my like terms, just to be nice to myself. 3 times negative 6x. And then 3 times 9, 27. What happens here?
Cancel.
Die. Now, normally, if I just made stuff up out of nowhere, that would not happen. Obviously, I was very careful of the numbers I picked. So today we're going to talk about how to do this backwards. If I gave you this, how do you go backwards and figure out where it came from? Is anybody very excited about that? You guys remember difference in sum of cubes?
Yes.
Yes? Okay. So you guys are like, I'm never excited. Okay. Yes.
So why does 2x with 4x squared become cubed?
Oh. So 2 times 4 is 8. Because there's a 2 and there's a 4, then we can get 8. There's an x, there's an x squared. When I multiply those together, how many x's do I have now? There you go. So it's x cubed. So it's 8x cubed. Is that cool? Yeah, you just gotta accumulate all the x's from everybody. Okay. What about these guys? Sorry, you suddenly had a very quizzical look on your face, like, what the hell is that? This one's not too evil, unless it's been a while for you, but do you guys remember, a lot of times when you're solving equations, you get to this level, and then you just have to pick a side. Which side do you want to put your x's, which side do you want to put, so the general idea of solving equations You try to get all your x's on one side, all your numbers on the other side, and you almost always divide last. So, how do I get my x's? Okay, you can do that. Subtract 5x. And that makes negative 2x. The 11 is still there. These are dead. Now, what's in the wrong place?
11.
The 11. So, how do I get the 11 over there? And 11. Ah. And then the last step is almost always
Divide by.
divide. Real quick, what if somebody did this? What would you say to that person?
They're wrong.
By the way, that is correct. They are wrong. Don't do that shit. But do you see, what would you say to them? If they were your friend and they said, hey man, what's wrong with this?
I would say why you
Say it.
I'll say why you do that, bro.
Can somebody tell me why what they did was wrong? What's the correct thing to do? Divide the thing. Why is dividing the right thing?
Being
It's not.
multiplied against it.
Because the operation is multiplication.
Yeah, do
What
the
are the negative
opposite.
2 and the x doing? Multiple. So it's the only thing that's going to cancel that. Division. Now, this is a very simple equation. Whenever you think something's canceling, make sure the operations are opposite. Yes? Because that's a really simple little mistake. And we're human, we're going to make freaking mistakes. So you just take a second to make sure, before I cross this shit out, does it actually cancel? So if I do this right, that would be nice, Jeff. Like you guys said, divide by negative 2. Now, did anybody subtract 3x instead? So instead of subtract, you can subtract 3x. That's what I normally do to keep my x's positive so I don't make a negative mistake later.
Yeah.
But there ain't a damn thing wrong with this. That's fine. Okay. What about part B? What's where your eyes drawn in part B? What do you have to do first? Yeah, what about the parentheses? Distribute, yes. Nothing to do in the parentheses, but I can distribute. What do you have to be careful about here? So like here, this is easy. 2x minus 2. What am I distributing here?
Negative 3.
Good. Negative 3x, and what was this? Positive 12. Over here, can't I go ahead and, is that okay? Can I do that?
Mm-hmm.
Put my like terms together? This side is completely simplified, this isn't, so we're going to take a second and simplify this side. Is that okay? There's a lot of different ways to do this problem. This is your standard textbook way. 2x minus 3x is negative x, and what's negative 2 plus 12?
Right on
Yeah. And now we're in the same place we were over here. I just pick up, and I'm going to do this. I'm going to keep my x's positive, and at the same time, I'm going to move the 4's over. Because ain't nobody got time for all this writing. There. Is that okay? So equations, solving equations like these, normally students can sink their teeth into that a little bit. Something you've done a decent amount. It's just unfortunate that the way we set these up, you get less practice with other things. But this is one thing I think you get enough practice with. Let me know if that's not true. Obviously, this semester we're going to talk about solving more complicated equations.
Yeah.
Did we? Does anyone know how to do this? Yeah, I was trying to say, did we do this, but we haven't done this one yet. Does anyone get this one? Do you guys think you solved this one? I got one person. Anybody else think they got this one right? You think so? You think so? You think so? Okay. One of you guys want to tell me? No. What'd you get?
I got like positive 7 or negative 7.
Say the whole thing.
Positive 7 or negative 7.
It can't be, it's not an equation, so I'm not going to get like number answers.
Like
I just want to factor this thing, right? So there's got to be x's in there somewhere.
x minus
You with
7
me?
in parentheses, and then times
Yes.
x plus 7.
So that's what I thought you meant. That might be what you meant, but if you do this, what's the idea here? don't I have two X's?
Mm.
So if I put one there and one there, don't I have two 7s?
Mm.
Now the reason that we cut both up in half, do you guys notice I don't have a middle term? Do I have a term that has just X in it? So I'm missing like the middle term. So what I want to do is I want that middle term to cancel. So if I make everything the same except the middle signs, the middle terms will cancel. And that of course is called a difference of squares. So if you see there's two terms and you have to factor it, it could only be squares or cubes. We'll talk about cubes later. Squares kick so much ass. You just cut everybody in half, plus minus, or minus plus, right? And maybe. So, if you get that idea, here, you ready? You can do it, Jeff. There we go. How many terms did I just write down?
4.
No? The terms have a lot of shit in them. How many terms are there? What separates terms?
I'll just
If I said x plus 7, how many terms are there?
do
2. Why did you say 2? What's in the middle of terms?
Oh.
Plus or minus, yes?
Okay.
So how many terms are there? 2. Where do you see that? They're just overloaded. There's a lot of shit in each one, yes? Can you cut everything in there multiplicatively in half?
Yes.
Right? 25 is 5 squared, 16 is 4 squared. All the other things have numbers, have x powers that I can cut in half. So this looks horrendous, but it's easy as shit. There's 2 terms. It could only be squares or cubes. If it's squares, you thank your favorite deity, and you just cut everybody in half. So here, this, if I cut him in half, what's half of this dude multiplicatively? 5, w to the, no, cut it in half,
5.
fifth, cut it in half, z to the 4. And if I put this over here also, if I start to FOIL it, don't I get this back? Like, of course I do. I cut it in half, so when I put it back together, I get a whole one. That's amazing. And then, what about this guy? 4 squared, 8th power, 11. So 4a squared, b to the 8th. So there's my 16, a4, b 16, yes? And then if I just put minus plus the middle terms, just cancel. Yes? Yes, sorry.
3 squared 4. 16.
What about 16? I'm sorry. Oh, I see. No.
Oh.
When you have powers, all right, what 2 numbers do I multiply to make 25? 5. What 2 things do I multiply to b to the 16th? B to the 8th times b to the 8th, right? I want to multiply by itself. I'm not taking the square root of 16 on the power, I'm cutting that in half. How are we doing?
So you just multiply the 8 x multiplied by 2, and that becomes 16.
No. If you FOIL this, what do you get when you multiply this by this? 16, a to the 4th, b to the 16th, yes? Because you add powers. It's because of the fact that we add powers when we multiply.
Okay.
So in this expression, let me say what I said earlier. In this expression, there's only 1/16. There's only 1/16. Does anyone have an issue with that? It's okay if you do, because who knows? Maybe I just went insane. Maybe I don't know math as well as I thought. Does anyone think there's more than 1/16? It's okay if you do. In fact, I don't blame you if you do, because you're like, what the shit did you write right there, Jeff? But what is that? That's not 16. What does that represent? What does that symbol tell me?
B times B times B.
There are 16 B's in a chain that we're like, I don't want to write all 16 B's. Do you guys see what I mean? I know that number is 16, I know, but it's not 16. There are 16 B's, yes? And when I cut that in half, that's 8 B's and 8 B's. Bam. Maybe. Okay. Okay. So, I'm gonna talk. Any questions on this warm-up sheet now that we've finished it? Any questions? Okay. I sent an email out earlier about the factoring workshop that's happening tomorrow. It's okay if you didn't get it yet. It's fine. You can come. You don't have to come to any of the workshops. You can come to all of them. I don't care. They're just there. They're an extra thing. I might go a little deeper into some stuff, but to be honest, I'm not going to do like a whole lot more than what we've done. I am going to have different problems, so you just get more practice. Does that make sense? Factoring is so crucial to almost any mathematics, and that's why I don't have a problem sticking with it for a while. Okay. In fact, at the end of the semester, we're going to revisit it. So when you take calculus, your factoring's on point. You'll be like ahead of everybody else. They're like, "Where'd you come from?" You're like, 171. Okay. All right. So any questions? Okay. So I want to introduce a couple of basic factoring methods, and then I'm going to shut up. I'm going to let you guys work in groups on a little handout to do some more complicated factoring methods. You're going to kind of explore that. Sounds great, John. How do I, do me a favor, let's start off with this. Whenever I explore factoring, I do the opposite, which is multiplying, right? I start with multiplying stuff to investigate unmultiplying. That's what factoring is. What would you do here to simplify this? Yeah, you would, what's the word? Distribute, right? So I would give each term inside a 5x. So put it here, what do you get?
5x squared. Negative 15x.
Now, factoring, the most basic form of factoring is called GCF, greatest common factor. And another better name for it is undistributed. I'm going to give you an expression like this, and you have to work backwards. So for example, if I give you, what you got, Jeff? Oh, I don't know. Let's do 6w cubed plus 24w squared, yes. What you're asking yourself, do you see how each of these terms has a 5 and an x in them? And then you're like, well, of course they do, Jeff. We freaking gave each of them a 5x. We now have to think backwards. What was sitting out front that would have ended up with this? So what number do they have in common? 6. And how many w's do they have in common? 2. If I try to take 3 w's out, is he going to be cool? Is he going to freak out if I try to take 3 w's away from him? Isn't he going to freak? So I call this the more fair than normal tax band. They'll take as much as you got, but not more. Sometimes they take more in real life. That's okay. So, remind me, what number did you just say comes out? So I can put a 6 out front. So I'm just doing this backwards. I'm saying to myself, what do they both have that would have been sitting out front like he is? That's the first step. They both have a 6, kick ass. They both have 2 w's. I'm going to put that out there. Now, you just go term by term. He had a 6, we took it. He had 3 w's, he took 2, so how many w's left? That's insane. He had a 24, we took 6 out, divided, so what's left? 4. Are you telling me 4 or you have a question? Okay, thank you. I was kind of weird, like, that would be neat if she had a question, she just accidentally got me. And then he had 2 w's, and I took 2 of them away, so he had 2, we took 2. No w's. There you go. How do I know I'm done? Is there anything still common? Nope, he's got numbers, he's got w's, they ain't got nothing in common. Do you guys see what I mean by undistribution? You're just thinking backwards. What must have been out front and what must have been inside, so that if I did multiply this. So when I distribute, I multiply, When I take something out, when I factor something out, I divide it. Kick ass. Kick ass. Alright, one other thing. So what if I had this then? So let me ask you the same question I asked earlier. How many terms are up there? Good. There's only 2 terms. They each have a lot of shit. What is M in general? Like, what is M? That's a weird question to know, but I'm still going to ask it. What's M? Do we know what it is? You do? You're like, that's the letter after L, man. Shit. What does M mean in this expression? What could it be? It's a variable, so it could mean any number, correct? So it's a number we don't know. Yes? It's a number we don't know. I'll say it again. What is x minus 3?
Variable
What's x minus 3?
be less than the variable.
Sure, but isn't x minus 3 itself a number we don't know? Do you know what number x minus 3 is? Same way we don't know what number n is, do we? You guys see what I mean? If I told you x was 7, what's x minus 3? If I told you x is 7, what's x minus 3? 4. You with me? Let me stop for a minute. When you factor, when there's little chunks like x minus 3, your brain thinks, oh, this is going to act a different way. No, it don't act different at all. How many x minus 3s does the first term have? How many x minus 3s does the second term have? So you can treat it the same way we just did the w's in the problem before. So let's do this step by step. What number can I take out? 4. How many m's can I take out? 1. How many x minus 3's can I take out? 1. Then you write what's left. X minus 3 acts just like the m does. Of course it does, because it's just a number I don't know. So they're going to act the same way. Our brain don't like that. It's like, that's a lot of shit. But no, it's just one number. I don't know what it is. It's just a number. So this had a 4, I took it. He had 1m, I took it. He had 2 of these, I took 1. What's left? Good, there's 1 x minus 3 left. He had an 8 divided by 4 is, he had 2 m's, we took 1. He had 2 m's, we took 1. 1 m left. He had 1 x minus 3, we took 1. He had 1 x minus 3, and we took 1 away, so he's got no x minus 3's left, yes? Can we stop for a minute, because that's always trippy.
Okay.
I got you. That's all right. If you think about it, we just did the exact thing, same thing we did with the m's. We did the exact same thing with the x minus 3's. Yes, there were 2 m's and 1 m, so we took 1 m out. There were 2 x minus 3's and 1 x minus, so we took 1 x minus 3 out. They act the exact same way. And we're done. Because I can't take any more out, there's no like terms. And I'm left with this times this times this. That is factored, yes? If I ask somebody to factor 8 and they say 6 plus 2, I'm like, okay, wait a minute. Factor means multiply, yes? So if you have a problem that says factor and your answer is blah 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 plus blah blah, blah you're wrong. You're automatically wrong. Factoring means make everything multiply. Break it up into multiplication chunks, yes? Okay. So, I think I might have lied a second ago. It's okay. One last thing. You can do it, Jeff. Can you? Sure. I think that'll work. We're all gonna find out. How many terms are up there?
3.
4. 4 terms, yes. 4 terms. Does anybody remember what to do if you have 4 terms you have to factor? So word starts with G. go with, no. Group, you have to group. I have 4 terms, so do I have a group of 2 at the front? Do you see anything these two have in common? So just kind of ignore these guys for a second. What comes out of these two?
2x.
Yeah, 2 comes out of 4 and 6, and how many x's? 2. And what's left? So 4 divided by 2, 2. I had 3 x's, I took 2,
X.
1 x, minus 6 divided by 2, 3. And I took the 2 x's away, bam. Do everything we just did again for those two. What comes out of these two?
5.
Good, 5. And what's left?
2 minus 3.
Now, what tells you we can do the next step?
There's 2x minus 3.
They both have a 2x minus 3. If one was 2x minus 3 and one was 2x plus 3, either it's prime or more likely you made a mistake. You might have factored a negative out and forgot to change the sign. That's what happens most of the time. These kind of problems, those two, if it's not prime, these have to be the same. If these are not the same, it's either prime or you messed up. But these are the same, so what can I take out? Do it again, sorry. Yeah, I could take a 2x minus 3 out, and then you can literally do this. What's left in the first dude? 2x squared. And what's left in the second dude?
5.
That's crazy. And this is not quite a difference of squares, because it's not a difference, and these numbers are not squares. So you can't go any further. Yes?
So, like, from the 2x minus 3, taking those away, you would just put one of the things of c with the minus 3 and one of the parentheses and put the 2x in the second parentheses.
No. So we took a 2x minus 3 out. If I take a 2x minus 3 away, 2x squared is left. Take a 2x minus 3 away, 5 is left.
Okay. Alright.
So this is because it was there.
Only one 2x.
So if I take this away, 2x squared is there.
Okay.
Okay. So let me finally shut up. So can you guys put yourselves, are you recording, you silly thing? Yes, you are. Put yourselves in a group. I know not everybody's done with it, but let's take a look.
Super long parentheses. Yeah.
So, in case you remember anything about factoring, this should be very familiar, because that's what it's all about. Two numbers that multiply to 24 add to be 11. I think everybody eventually got there. Like, you can't be 4 and 6 because they add to be 10. It can't be 2 and 12 because they add to be 14. It's got to be 8 and 3 because they add to be 11. I like it. What about this one? What's got to be true about the two numbers besides these two things? What kind of signs can the two numbers have?
One has to be positive.
Yeah, they have to be different signs. So, when I say add to 6, you can actually think they have to be 6 apart. They have to subtract to 6 because they have different signs. Is that cool?
Yeah.
So now you can either start making a list of numbers that multiply to be 40. Or you can say, what are two numbers that add to be 6, knowing that one of them is negative? So for example, 8 and negative 2. Do they add to be 6? 8 plus negative 2. What's 8 minus 2? What's 8 minus 2? 6. So do 8 and negative 2 make 6 when you add them? Am I having an episode? 8 and negative 2. If you add them together, you get 6.
Yeah.
Well, what is 8 times negative 2? Which is not negative 40. Damn. So keep going. What about 9 and negative 3? They had to be 9 and negative 3. They had to be 6. What do they multiply to be? Negative 27. Closer. So what about 10 and 4? What about 10 and negative 4?
6.
Yes. Okay. So you could either make a list of things that factor to be this, Or you can make a list of things that add to be 6. It doesn't matter which one you make work first. You just have to make both work. And what about this one? If they add to -1, they have to be really close. They have to be 1 apart from each other. And what two numbers multiply 56 that are 1 away from each other?
8 and 7.
8 and 7. Which one's negative?
I would read -8.
Good. The 8's negative. Get out of there, Jeff. So that they become negative at the end when you add them together. Okay. So, the reason, just to show you a little bit of how I try to, it's called scaffolding. That first step is non-algebraic. It's just playing with numbers, yes? The better your number sense, the quicker that first 3 were. The second step is algebra, but what we're doing opposite, what we're doing in reverse, just to show some motivation. So if I multiply, what'd you guys get when you FOIL this out? Now, can you tell me, just looking at these, where'd 20 come from? 4 times 5, and where'd 9 come from? 4 plus 5, right? Two numbers that multiplied to be one thing and added to be another. This one you get 16 came from 2 times 8, 10 came from 2 plus 8. This one you get, what do you get? 12 is -6 times -2. -8 is -6 plus -2. Is everybody with me? And we got Feng Shui class going on somewhere. X squared minus 4x plus 7x, so plus 3x minus 28. This was -4 times 7. This is -4 plus 7. Yes? I guess kind of with me. So that the first 3 problems aren't up there are the main heart of what you need to be able to do to factor. What we just did was unfactor. We simplified. That's the opposite of factoring. So let's actually freaking factor on this factoring worksheet. That would be amazing, Jeff. By the way, little typos here, yes? Please give me some grace. Thank you so much. So here, the question is always going to be, so see how the first thing has got 1x squared? So I know it's going to come from a binomial times a binomial. 2 terms times 2 terms. X squared comes from x times x. So that's a known thing. I just know that. It's the numbers I don't know. And the numbers have to multiply to be 12, add to be 8. What'd you guys get? 6 and 2. Here, same idea. X squared, so it's x and x. They have to multiply to be 20, but add to be -12. So if they multiply to be positive 20, they have to be the same sign. Add to -12, so they both have to be negative. So what do you guys get for that? -10, -2. Those multiply to be 20, and they have to be -12. Kick ass. Shabbat. Same thing here, x squared is x times x. I just need the numbers that make it work. What 2 numbers multiply by -60, add to be -11. This might have taken you a second because it's and 4. 16 and 15 and 4, thank you. Which one's gotta be negative? Okay. Is everybody doing all right? Okay. Part D. Okay. Everything we've done so far is assuming the first number is a 1. If the first number is not a 1, things get a little more complicated. Whenever the first number is not a 1, I pray to my favorite deity, dear God of coffee, can something come out so I can make a 1 in front? So look at part D. It could be a gross problem because there's a 2 out front, not a 1. But what can I do? What can I do to get that 2 out of the way? I can take it out. First thing I always try is GCF. So if I take a 2 out, what's left? Yeah. And now that I got the 2 out the way, there's a 1 here. Now I can focus on the numbers. I know this is going to be x and x. Yes? What 2 numbers multiply before, add before? 2. 2.
Yeah.
And if you wanted to, if you're feeling really, mathy, you can make that 2 times x plus 2 squared. If you stop here, you're fine. How we doing out there? I'll take that as okay. All right. Part E, I was telling people as I was walking around, if the middle term is like a 1 or a negative 1, the 2 numbers have to be really close to each other. Yes? They have to be different signs, and they have to subtract to be negative 1. So they have to be right next to each other. Yes? And what 2 numbers right next to each other multiply by 72?
9 and 8.
9 and 8. Which one's negative?
Negative 9.
Good. The bigger one. And then finally, for 2 reasons. Number 1, I got an A++ in my evil class that every math teacher has to take. But also, I got to remind you that I created those problems to work. If I just plop numbers and letters out of nowhere, it's almost definitely not going to work. Are there 2 nice numbers that multiply by 7 and add to 3? Holy shit, no. In fact, the only 2 numbers that do that are imaginary. They're complex. So
We're not gonna do that.
we're just going to say, in this case, it's prime.
Oh, yeah, it's a problem.
Yeah. What do you say when you can't factor a number besides 1 in itself? Prime. Okay. Now, in the interest of time, I know a few of you guys have turned the paper over and started working on the other side. I kind of want to do that with you a little bit, because this gets a little bit freakier. Actually, I tell you what, you guys can do these 3. If you haven't done these 3 yet, go ahead for it, and then that'll give me something to reference. So if you haven't multiplied those first 3 problems, do that real quick. If you have, just sit there. Stare at your favorite wall. Oh, Christine, over if you need some help for me.
You want to check this real quick?
To do what?
You gotta check our work.
Yeah, let me see. Then oh, I forgot about that. Yeah, shoot. You're okay. You'd be a little bit. My arm.
I know that micro. I know the micro 10.
Yeah. This is like my standard motions.
Bro, I just like down to 425
Bro.
All right, guys. So, did you get that stuff there? Does it look familiar or no? Thank you. Now, do you see how the middle term comes from a combination of the first and last numbers? Like that 14 came from 2 times 7. So the fact that there's a number out front messed everything up. So it can't be as straightforward as the front side. If the first number's a 1, 1s don't screw anything up. We're like, thank you. What is 14 times 15? If you read this, you should know. But what's 14 times 15? So it is? 210, because it says so right away. And what is 6 times 35? Yeah. 14 times 15 is 210. 6 times 35 is 210. What is 15 times 12? What's 15 times 12?
180.
180. And what's 10 times 18?
180.
What is 14 times 15? 210. What is 35 times 6? 210. Okay. The first number screws everything up. So instead of finding factors of the last number that adds to be the middle, I find factors of this times this that add to be the middle. Okay, maybe. Maybe. So let me do an example. Because this times this is the same as this times this. So if I'm given a problem like this, the first step, since the first number is not a 1, what's 3 times 8? 24. I find factors of 24 that add to be the middle number. Because it's not fair to find factors of 8 to add to 10, not because there aren't any, but because the 3 is going to mess things up. So I'm sorry, what two numbers multiply 25 to be 10? 4 and 6, kick ass, or 6 and 4, whatever way you like to say it. Now, does this look familiar to anybody? Does anyone remember doing this kind of factoring? A little bit?
It's been a long time.
A little bit? I'm kind of happy about that, it's fine. Because there is a method that my colleagues teach that I keep trying to tell them to stop teaching it. I'm not even going to tell you how it works because the hardest part of this problem is what we just did. This problem wasn't that hard because the numbers weren't very big. 6 and 4 weren't very hard to get. Here's what we do. We did a grouping problem earlier, yes? And if you think about it, grouping is not difficult. It's 2 little greatest common factor problems. Do you all agree with me that 6 plus 4 is 10?
Yes.
Therefore, 6x plus 4x is 10x, yes? So I can split the middle term up using these coefficients. So I can rewrite this as 3x squared plus 6x plus 4x plus 8. So on one level you could say, great job, Jeff. We got one more term than we did. Thanks, man. But now I can group. Now, I really want to stay with me. This is kind of cool. Is there another way to break 10 up? Can you make it 9 and 1?
Yeah.
Can you make it 8 and 2?
Yeah.
The only way the grouping works is if you use the numbers you got here. That's the trick. So if the first number is not a 1, you got to take it into account, find the factors, break up the middle dude. Now, group. What comes out of those two? What comes out? What number comes out? What number do they have in common?
3.
3. And how many x's can I take out? 1. And then what's left? 3 divided by 3 is 1. I had 2 x's, I took 1, I have 1 left. And then here, 6 divided by 3 is 2. I had 1 x and I took it. Poor little dude. What comes out of these two now? 4. 4x divided by 4 is x. 8 divided by 4 is 2. How do I know I'm on the right track?
Because they both match.
If these don't match, more than likely you made a mistake, or it's maybe prime. But don't go the next step. I always get students who do the next step, but these aren't the same. That's neat. So I can take out an x plus 2, and what am I left with inside? I take an x plus 2 out, I'm left with 3x plus 4. Yes. By the way, real quick, if I took this whole thing and multiplied it in, do you see how I get this?
Yeah.
And if I multiply it over here, don't I get this? That's all I'm doing, yes? I'm taking x plus 2 out because if I multiply back in, I get back to where I was. Okay. Did anyone have a different way they do this kind of problem? Sounds like most of you guys haven't done it in a while. Can you explain to me your way?
It's like a square. I put
Oh yeah. Square thing always trips me out. So real quick, you put a square, but then where do you get the numbers that are go here and here, here and here? Isn't that how it works?
Yeah, I put the ones in there first. Like I know the one the bottom right one is gonna be whatever the whole number is, so like 8.
Yes?
I put 8. No, like in this one.
Oh, in the square.
Yeah, 8. And then the
This is
top-
3x squared, yes?
Yeah, 3x squared.
How do you know what happened here and here?
Just know that they both add to get 10x.
Sure.
I'll do like
So you have to guess?
I just like just multiply because I put 3x on the outside of the 3x squared,
Okay.
then I put x on top, yeah,
Sure.
and then I add 2x or 2 to the x on top of the box. Yeah, that one.
What do you mean?
Like the box, the top right box on top of this.
Here?
Yeah, I add 2.
You add 2.
Yeah.
Why?
Because 2 times 4 is 8.
Sure. So why not put a 4 here?
Because when I do 3x times 4, that's not going to give me 8.
Okay, okay. So it sounds like, because I see a lot of people doing this kind of thing, it sounds like if you're better at playing with numbers, you're better with that. So as long as you show me some work and it makes logical sense, I'm cool with it. In case this is true, in case anybody ever has been shown to find these numbers and then divide by the first number, don't be doing that shit. It's called bottoms up method. And I will only let you use that. It looks like most of you guys have never heard of that, which is great. Keep it that way. But if anybody does that, I will let you do it as long as you explain to me exactly why it works. And in all my years, I've had one student do that. Okay. But this method is not that terrible, is it? It feels a lot like what we were doing before. I just have to first take that number into account. Yes? And then I make a grouping problem, and grouping is relatively nice. So hopefully we can agree on that. Grouping is not terrible. That's what you think, math boy. Okay. So, can you guys try part B out? If you've already done it, great. Sit there, wait a minute. Oh yeah, I forgot all about that. Doesn't matter. Yeah. Okay. Yeah. Forgot about that. Okay. Yeah.
This is a positive 6. I'll do it right now.
Yeah. Then you can go to
This looks correct. Six and four.
Oh yeah, what's that?
Also add up to 10.
Kick-ass. Yeah, the three is
So I just like very good with last week, so you just take.
What do they both have?
They both have X minus two.
So you take it out in front, put that out front.
So it'd be.
X minus two parentheses. Yeah.
Two.
Good. Go ahead and see what's left.
4x plus 5, in parentheses, is 2x, minus 5. So when you take, for this, you take out 4x. Because it's ax squared, minus 20x. So when you take out 4x from that, you get 2x minus 5. Yeah, and then the 5, you also take out, you take out a 5, so then it's, 2x minus 5 again. Yeah. When you like add everything and it gets to a certain number, I learned that last semester also, but I'm just like, I saw it and I was like, oh yeah, I remember that. But dude, it's been so long. Well, I say it's been so long, it's been like 2 months. Yeah. It's like, I took the class, but like, I was just like, at the very end, I was like, yeah, you know, and I was like, I'm not even, now I didn't even drop it. I just like, yeah, well, cause I couldn't, so what happened, right, was cause I was talking to my counselor, and it was kind of like a rush, I guess, so like, I didn't really get down to talk to her, but I only took 3 classes last semester, which I was trying to take 4, and, you know, because I didn't take 4, I only had 3 classes, and so for FAFSA, you need like a certain amount of credits. Yeah, so I literally just had to like stick it out because I needed the credits. So like, I just put it in the past. So it doesn't actually show up in your transcript as like an F or an E or whatever it was, but it just shows up as I know pass. So it doesn't actually affect your transcript, but it does affect your GPA. Yeah, so it was like.
Oh, this is
Like,
it's every, it's
So it wasn't like terrible.
not a class, it's like you have to roll it.
But
it's right next
so it's
to
just
that.
like, yeah, you just didn't pass the class, but it doesn't pass.
Alright guys, let's take a look here. So, first number is not a 1. And unfortunately I can't factor a 5 out, so I'm stuck. So gotta do 5 times 6. What factor does 30 add to be negative 13? 10 and 3, as long as they're both negative, right? So then I take the middle term and I break it up using those numbers. Now, if you put a 3 here, a negative 3 and a negative 10 there, it'll still work. It doesn't matter what order you put those numbers, but it's got to be those numbers. What comes out of these two? 5x. And you're left with x minus 2. Good. And then what comes out of these two? And the trick is, I know I need the x term to be positive, the number term to be negative. So don't just take a 3 out. Take a negative 3 out. Negative 3 divided by negative 3 is 1, so that's just 1x. 6 divided by negative 3 is negative 2. And I know I'm on the right track because those are the same. Those being the same is what allows me to do the next step. What can come out of both? X minus 2. And then you can literally just do 5x minus 3. And if you have time on a test or quiz, you can just FOIL this back out and make sure it becomes that, just to check it. Okay, kick ass. Hopefully, kicking the ass in. And then finally, same thing here. There's no number that comes out of all three. That's too bad. I'm not gonna have enough room. Somebody got this one here? Okay. So when I do 8 times 25, 4 times 25 is 100.
200.
So 8 times 25 is 200. Negative 200. This one should be 2 evil. What multiplies to be negative 200 and adds to be negative 10?
Negative 20.
Negative 20 and 10. Yes? Now, listen. Obviously, if you're decent at manipulating numbers, this will be easier. If you're not, you are allowed to use your calculator. But I want to show you something. 200 is 40 times 5, right? Yes? You with me? 200 is 40 times 5. Alright. But obviously it's not 40 and 5, correct? You with me? No matter which one I make negative, it's not going to make 10. 40 is 4 times 10, so 4 times 50 is also a way to factor it. Do you see what I mean? So if you get it to factor one way, you can actually mess with those factors to make new factors. Yes? But the better you are, the more comfortable you are playing with factors and numbers, the easier this is going to be. It just is. So like when I took painting class, I never really painted in my life besides finger paints. So a lot of other students have been painting since they were 3, and I'm like, I don't know what this shit I'm doing. So it's just a matter of, what do you come in with and what do you don't. If you don't come in with this greatness, you can start to figure out how to recombine stuff. Or use your calculator to help you whittle it down. So we got negative 20 and 10. I break the middle term up. If I have a choice, I always put the negative one here because a minus sign here could mess me up. What comes out of these two?
4.
And?
4x.
4x, good. A divided by 4, 2. I had 2 x's, I took 1. What's 20x divided by 4x? 5. And it's negative, good. And what comes out of these two?
That would be 5.
5. And thank the gods, 10 divided by 5 is 2, 25 divided by 5 is 5. These are the same, which tells me I'm golden. Last step is going to be, what's the last step? Since these are the same, what can I do? Take it out. I'm left with 4x plus 5. Crazy shit. Now, before I forget, I'm going to let us out a little early, but I want to show you a couple things. It's easier to see for the ones we did on the front, I think. I always forget to do this, but this is so freaking cool. Do you guys see this problem, for example? Okay. And you're all like, yes, Jeff, you just pointed at it. Thank you so much. What could x be in that expression? And I love this question because I don't know what you want from me, Jeff. I'm not asking you to solve anything. Just what could x be? Anything. It could be any damn thing. You can make it 3. You can make it the square root of 11 if you're feeling weird. You can make it pi. Let's not do any of that shit. What if I made x 6? You with me? Wouldn't this be a number? So let me figure out. Why did I pick 6? I don't know. I just picked 6. I could have picked any damn number I wanted to, yes? So what if x is 6? What number is this? It would be 36 minus 72. Is that cool? Just plugging a 6 in? Plus 20. What is that? 36 minus 72 is negative 36. Plus 20 is negative 16. Yes?
Yep.
Now, is everybody cool with that? You could have picked any number you wanted to besides 6. You could pick 6. You could pick whatever the shit. So if x is 6, this number that I started with is negative 16. What is this if x is 6? What if x is 6? What is this?
Negative 4.
-4. If x is 6, what is this?
Positive 4.
Is that a way to factor -16?
If it is.
Do you understand what I'm saying? So here's the reality. I need you to really understand this. When we factored each of these, we factored an infinite number of numbers. Does anyone understand what I mean?
Yeah.
How many things could you replace x with? Infinite number. Yes? 1, 2, 3, 4. Never stop. Holy shit. Yes? And you would get a number for this, and this would be a way to factor that number. Yes? So you literally are factoring an infinite number of numbers when you factor any of these expressions. That's a little tricky. Somebody's like, what'd you do with your data? Factor an infinite number of numbers. What the shit did you do, lazy? You guys go with me? You don't have to say that. What did you do? Okay. And you can do that with any factoring problem ever. This is actually a way to check your work. So if you just pick a number, see what number that is, and make sure that these actually multiply to be it, it's a way to check your work. You don't have to do it ever. You never have to do it, but you can if you want to. Now I'm going to do myself and you a favor. I'm going to let us out a little early. Don't get too used to it. I will normally let us out early. Not normally this early. So tomorrow, just to let you know, we're having a guest speaker come by for a little bit. They're going to talk about success coaches and such. I said a little bit about it yesterday. Tomorrow's also the factoring workshop. The first one next week is another factoring workshop. You don't have to go to either one. You can go to both. I don't care. If you have any questions, let me know. Otherwise, I'll see y'all tomorrow. Oh, yeah, shoot. Oh, man. What's up, man?